guys, this video will cover FreeRTOS, free real-time operating system. So what is FreeRTOS? FreeRTOS is a lightweight open source operating system designed specifically for embedded systems like microcontrollers. So instead of wiring your entire application in a single while loop, FreeRTOS allows you to split your code into independent tasks that can run concurrently. I may not go deep about that, so this video assumes you know much about RTOS operating system. So let's dive deep. So we create new projects. Choose the MC you are using. Give the project name. I will configure my clock to run at 400 megahertz. (400 megahertz). All right. Remember to change the time base to timer 6, or you can use timer 7, but I prefer using timer 6. FreeRTOS version 2. In configuration parameters, in config parameters, I will leave it as default. I will leave everything here as default. Yeah, use task notification, heap 4. This is the total heap size. So go to tasks and queues. We have the default task, one task. So I will change the name, task 1. So the priority is normal. Stack size in west 128. Entry function stack task 1. So I will add another task. I will add the second task. I'll make the priority more lower. I will add Q. The Q size should be 10. Go to timer. Okay, let's add up mutexes. I will add one mutex, mutex 1. I will go to timers and semaphores. So I will add binary semaphore. It should be available at initial stage. I will enable use new lib because I'm going to print. So I think that is all here. This is the serial wire debug. Because I'm going to print on the screen. Save to generate our code. So I forgot to, I will set our LED pin to output so we can toggle it. Down here, this is first task, second task. This is where we write put our code. So I will go to this. I've written it down already. I don't want to mess things up. So I will start with Q. We're going to configure three major features: Q, Mutex, and Semaphore. I will start with Q. So we put Q is a feature to, we want to put this variable here. We will put this variable in the Q. In the task one we put this variable in the Q. So the second task is going to read the Q. It's going to read the Q to get what is in the Q. So we are putting this variable count into the Q. It has initial value of 0, but later it will increment. So when it gets to 10, it will reset back to 0. So at the time of this task is 100 milliseconds. So we have set the count variable into the queue. We are is in the queue right now. So the second task is going to read the queue. So this is our second task is going to read the queue. So it will read the queue and store the what it gets from the queue. It will store it inside the read value variable. So if it has the data from the queue, it will print the value, to print the values. The data read from the queue, it will print the values. So you can put any other thing you want it to do here. You can add any other job you want it to do, maybe toggle pin, set pin, or any other thing, etc. So we are going to change the system call so we can print on the screen. We redirect it to print with ITM console. I'm going to make some changes here. Oh, we have some errors. So the error said Q01. Okay. All right. So the name of the queue is Q1. not 01. So okay, it's successful. This is the name here, Q1, not Q01. So let's debug it. Enable the serial wire debug, the serial wire view. The clock log. Enable this and this. All right, something is not right. Okay, we have to turn it on before it will start printing. All right. Okay, it's working now. As you can see, it's working perfectly. So it is working perfectly. The task 2 is reading from the queue. So this is it. It will increment from 0 to 9 and it will reset back to 0. So it is working perfectly. So the queue is working. I'm going to comment out all this to configure the mutex. What the mutex does is the mutex allows each task to access a resource. So the mutex allow task to access a particular resource, to share the resource. So in example, uh, we will increment the variable share here. Each the two tasks, the task one will acquire the mutex and increment the share variable. It will increment the share variable. So after that, acquiring the mutex, it will release it after sharing. After using it, it will release it. Then the second task is gonna get it and also increment the variable share. So there, the two tasks are sharing one resource, which is the variable share. So that is what Mutex does. It will prevent any conflict The first task, acquire the mutex and use it and release it. The second task, we do the same. So we have the variable here, share. The initial value is 0. So both of them we increment the share variable to the value of 10 before resetting to 0. So each task we print each task will have to print on the screen. So let's text our code. We add the share in live expression so we can see the value. We see how the value increments. All right. Okay, the print is not working. Okay, I think it's okay. Okay. Uh, oh, okay. Okay, we need to put new line there. Okay, we add new lines. Add new lines. All right. Okay, let's check again. Okay, it's now working fine. So as you can see here, the increment by 2, 2, 4, 6, 8, 10, 2, 4, 6, 8, reset back to 0. The task, each task increment by 1, is each task increment by 1 at the same time. So what happens there? One increment, it release, another one acquire, increment, release. They happen simultaneously at the same time. So as you can see, the tasks are working fine. So let's implement the semaphore. I will comment out all this. I'll comment out all this one. The work of semaphore, what's the function of semaphore? Semaphore is a signal, is like a signal, it's signal task. When interrupt happens, or it will signal the task to do a particular job. So that is the work of semaphore. This is binary semaphore. Only one task can uh, can acquire it at a time. So until it releases, another task can acquire. So we are going to set our onboard key, the onboard key, the onboard button. We are going to set it as input. So I'm going to set it as input. So as you can see here, this while loop, it will, when the button is pressed, it will release the semaphore to complete the loop. So when the button is not pressed, it will remain at 0, and this while loop says when it's 1. If it is 1, it will not release the semaphore, but if it is 0, the code will continue working. So it means that when we press it, the code will stop working, but when we leave it, the code will continue working. So pay attention to the board. You will see. All right. So we press the button. Okay. It has stopped blinking. We leave the button. It is blinking now. Once we press the button, it will stop blinking. All right. Can you see that? So the the code is working as expected. Thank you for watching this video. Subscribe for more videos. Have a nice day.